Greetings, the Astro 30 here yet again, and back up on the desk here is this Sonance Sub 10-150. Now, in the last video on this, I did do a test on it and it doesn't appear to be putting out its full output power as it should be. I also noticed when I was editing that on the scope screen it was saying around about 6.5 volt before clipping, that's peak to peak. But I was also testing the output signal with it connected to the dim bulb, so that's going to limit the current. So I believe there is issues with some other electrolytic capacitors on this board. Now, this 10 microfarad capacitor down here at the input is measuring 4.6 microfarad on my meter, and this 47 microfarad is not measuring at all. That could be a problem, because that's right near a TL071 op-amp IC, and I'm not sure what that purpose of that IC is, but it may be part of the signal path. However, what I want to do first is, without the dim bulb connected, I want to put this onto an oscilloscope and input signal and see how much power this amplifier is actually producing into an 8 ohm load. Alright, got the test equipment set up, so I'm pretty sure that it's safe to plug this in directly. There went the relay. I can see something on the scope screen, although I can't really see the signal. I'll wind up the frequency. I might change my frequency to the 100 Hz range because I can't really see it on the screen and I can't be bothered. There we go. So we've got a signal pushing around about 4.1 volt peak to peak out, which is not a lot considering that these are rated 150 watts. So I'm going to increase my amplitude, preferably turning the control the right way, and yeah, that's its maximum. It's only, well, without clipping, it's only about 6 volt. It's only pushing out a watt, which is fairly pathetic. So what I'm going to do is I'm going to pull out the main circuit board again, and I'm going to change out those two capacitors that I already know are bad, or at least testing bad, one of the two, and see if that makes a difference. There's a few other electrolytics down here that I might want to change as well, but I'll get to that a little bit later if it proves that that didn't fix it. Okay, time to do something constructive then. Okay, that would be both capacitors changed. So all I've got to do now is put it back in for testing. Yes, I have redone the output stage grease here. So, is it a waste of the grease? No, not really. I've got some more. So yeah, gravity can be so annoying sometimes. Alright, so get this out of here. Move that over there. Now, I'm probably not going to bolt the output stage in just yet until I've tested it, because I'm probably going to have to pull it back out again. So I'm just going to put a couple of screws into the board to hold it to the chassis, plug some things in and test again and see what we get. But I do know that that 47 microfarad that I've just changed was completely open, well, at least according to the meter anyway, because the other module, which I've already replaced the 10 microfarad on, that 47 microfarad over there measures around about 26. So I don't know whether it's starting to go bad, but yeah, I'm going to leave that off as well. Alright, so I guess it's time to turn it on and see what sort of power we get. Alright, hopefully nothing goes up with a bang. Everything's clear. There goes the relay. It does tend to actually help to connect the output to the oscilloscope, because I haven't even done that yet. I got a little bit too carried away with myself to bother to do that, which is why we don't have an output. Right, let's try that again. Ooh, we've got an even stronger output now. Wow, yeah, now that is a hell of a lot better. Now that's what I call an output. So I put my oscilloscope on the lowest setting. I'm going to crank the volume, got to be careful of that output stage though. Wow, it's even off the screen, so that's still too sensitive. Right, we're clipping there. We are getting, easily 69.5 volt peak to peak. Alright, turn that off before it overheats. Oh, that's awesome. So it looks like to me that this module is actually fixed. I will hook it up to the subwoofer after I've put all the screws back in, just to make sure. I was going to replace some other components, like other capacitors, but it looks like I don't need to now. So that's awesome. And that's 75.4 watts RMS, by the way, into 8 ohms at 69.5 volt peak to peak. What's its peak? Well, we can calculate that. We know it's 69, I'll make the math easier, 70 divided by 2, which is, well, 35, multiplied by itself equals that divided by the load, 153 watts peak, and that's where they're getting the 150 watts from. And considering the topology of this amplifier and the voltage that it runs on, which is 90 volts, that's plus minus 45, because it's a it's a 35 volt secondary transformer. 70 watts to 80 watts would be about right. If they had double the output stage, like they've got facility for, then yeah, it'd be probably more closer to 200 watts peak. But it's good to see that it's actually now working and working properly just because of 2 bloody capacitors. Alright, so I don't know how well you can see that screen, but I'm going to measure these capacitors. That's the 10 microfarad that I've got in my hand at the moment, which you probably can't see because it's off screen. I'm going to just test these out of circuit. And yeah, 5.38 microfarad. And it should have come up to 10 microfarad by now. Let me test a good known 10 microfarad capacitor, because I've got 2 of them. And bang, 9.7. So that 10 microfarad is bad, or it's probably starting to get a high ESR. An ESR meter would prove that. I don't have access to one at the moment. Now this is the 47 microfarad that I've got now on the test leads, and it's testing bugger all. Let me change the range to 500 microfarad just in case. No, it's dead as a door now. That capacitor is completely open. Test a known good 47 microfarad. 46.9. So that's definitive that those 2 capacitors are, for want of a better term, f***ed. I'm ready to test the second subwoofer module now that I've just repaired. I've got it hooked up to the subwoofer, control board and its speaker. It's probably going to be pretty loud, so I'm going to turn it on and I'm going to kill the power quickly if there is any strange noise. So here we go. Ooh. I would say that is working. Are the amplitude too high? Now, that's enough to rattle the windows, and it's not even anywhere near to close to 10 watts yet. So that is a successfully working module. I am happy. Alright, I'm ready to power test the other module now. This is the one where the relay doesn't engage, and I had to force the audio signal into where there should be actually plus 5 volts there. So there's probably another capacitor near where the relay driver is, probably this one behind the filter cap that's gone bad. That's a 1 microfarad 100 volt cap though, and the only ones I could find was, 4.7 microfarad 100 volt, and the only ones I could get were 4.7 450 volt. Anyway, let's plug this in. and I can't see much on my scope screen. We have currently 7.1 volt, so let's see by winding the amplitude up. Interesting. This one might actually be outputting its full power. A little less, about 54 volt, okay. So what does this mean? Well, it means I'm going to have to probably replace the 47 microfarad capacitor on this one as well, because it only measured about 26 or something. And look to replace all the capacitors over this side too. There's only, well, 1, 2 really, 3. So I'm not sure which one's actually responsible for the relay delay constant. There is a 10 microfarad 25 volt capacitor here, I believe it is. So what I have to do is measure the capacitances now. Actually it's a 1 microfarad, but let me see if I can actually test this capacitor in circuit. It just says overload, so okay, it's really hard to know. I believe it's this capacitor here, which is nearest the relay. That's actually measured, well it was, measuring about 9 microfarad. 14, 15. It's going all over the place. Okay. So whatever you are, I think that's the 10 microfarad. I might change him out as well, just in case. Okay, that's the two capacitors changed, the 47 microfarad and the 10 microfarad 25 volt respectively. Why didn't I change these in the first video? Well, simple reason is I didn't have them at the time. And secondly, I didn't think that was actually the problem. And I didn't actually realise what the real problem was, because I was still in a learning curve as to how this circuit actually worked. So now I know that it works, or how it works. I'm going to put this back in with a couple of screws holding it in. I'm not going to bother to tighten the output stage at this stage. I know I'm getting some output power out of it. So what I'm going to do now is I'm going to see if I fix the relay circuit. If not, I'll look into other components. Nothing. Okay, so there's an issue somewhere else still. What I'll do is I'll plug this little connector in to the input, and I'll just measure the voltage at the blue wire and ground, just to see what voltage we've got there. Naffle 0.7 of a volt. Okay, it's time to investigate the circuit a little bit further. Well, I started testing diodes and I forgot the thing was still plugged in, and I was testing D202 here, which is the one in between these other two diodes, and the relay started clicking in and out, which was interesting. Well, I'll just demonstrate to prove that I'm not going insane. So something's wrong around this circuit here. From what I can see, and I don't know how well you can see it, roughly where the diodes live, these three, the joints look awfully terrible. So I might give all these joints in this area a bit of a reflow and see if that cures the problem. Okay, the diodes are reflowed. Still refusing to work. That's really disappointing right now. Not 100% sure what's going on here, but so I don't know why me putting the multimeter as a load across it makes the relay work, but it won't work without it. Okay, it looks like I'm going to have to really investigate this circuit thoroughly, because there's something not quite right. Now, whether the multimeter is adding a little bit of capacitance across that diode, I don't know. But yeah, I'm going to take a break from this and do something else for 20 minutes or so and ponder on it. Okay, well I'm no closer to fixing the relay yet. I will have to probably measure resistors and any transistors that may be in that area just to make sure that they're functioning correctly. Not that there is any, but there are resistors. Anyway, what I want to do now is I want to test what its actual output power is now that I have replaced that 47 microfarad capacitor. So I'll plug him in and turn the amplitude up. Oh, that's a lot better. We're getting 67.5 now. Not close, not quite the same amount as the other module, but it's pretty close in power. So it's going to be around the 140 watt peak, 45 watt peak, and probably 70 watt RMS. So yeah, so we now know that the power output is fixed, for want of a better term. So now, what is going on with the relay drive circuitry? This, I don't know. So I'm going to have to go through and test components in that area just to make sure that they're not open and they're functioning. It could be just something as simple as an open resistor. So that's what I'm going to do now, off camera. I'm not going to bore you with that. And see what I come up with. Well, this is interesting. I was watching the voltage on the multimeter across the blue wire and the ground start to increase from 0.8 of a volt up to 1.4 volt, and the relay went click. I believe the relay is now actually engaged. So there's a slow increase in voltage, because it should be close to about 4.5 volts. So I reckon there is definitely a capacitor there somewhere that's not right. Not sure which one at this point, but that's a good sign. That indicates to me now that the relay is engaged. Therefore, if I measure the DC offset on the output, we indeed actually have 0 DC offset, but it's moving around, so that indicates to me the relay is engaged. If I unplug it, I believe the relay went away. Not that I heard it very well, but let's check this DC offset again. There's nothing there. Can I plug it back in? And there goes the relay. Because whatever hasn't discharged. Gee, that made a lot of sense. Whatever is still charged hadn't discharged. So the relay is engaged. Therefore, we should actually be able to see an output on the oscilloscope from the output terminals. That would be an affirmative. Alright. So because the thing isn't actually hooked to the heatsink at the moment, the transistors are only barely touching the heatsink. I'll just not do that for too long. So that is pretty interesting. There's obviously a capacitor somewhere on this board that is not functioning. So if I measure across these two connections again, well, we've got nothing now. Nothing. So I'll plug it back in. And we've got 1.7. So what I'd need to do is let the thing discharge for a while and then go about changing out some capacitors. I've got, yeah, it's really hit and miss at this stage of which one I should change. But I probably should change these two down here. But one's pretty large though, unfortunately. Well, ha! And it's always the last capacitor you change fixes the problem. I've changed every capacitor now. Unfortunately, a lot of the pads on the other side, like where the blind pads are, it doesn't actually have a trace on it, just started coming off. It's a really cheap, poorly designed circuit board. But it turned out to be the 4.7 microfarad 100 volt capacitor, which is now this large one here, which is now 450. But if I plug my lead in to PCB, preferably the correct way around, and I just look at what voltage is coming out of that connector now. 6.1 volt DC. That's probably pretty much what it's supposed to be. So now I'll connect it to its input board. I'll unplug it first, just to see if it's not going to affect it. Nope. I'll re-measure that voltage now. 6.1 doesn't affect it. Okay, cool. So that looks like it's a working module. Now to test the output power. Alright, got everything set up. So plug in, turns on. I can see there's an output. Yeah. I can really hear that transformer humming though. Yeah, okay. Let's test it on the sub box now. I don't know if this board actually works or not, but I'm going to confirm a couple of things here. I want to make sure that I've got all the voltage supply rails, because I've messed around with these 220 microfarad capacitors. Plug that back in. Now between ground and this wire, change the speed, sorry, to height. 15 volt, minus 15 volt. Wonderful. Okay, I'm ready to test this one now. I can quickly turn it off if there's a problem. So contact. Well, okay. There appears to be a problem. There we go. Where's the amplitude? There. I would say that would be a yes. I had the frequency too high. Oh, that is awesome. There we go. That one works as well. So I'm happy about that. And I'm going to end this video here. If you enjoyed it, please remember to rate, comment and subscribe below, as usual. Links are all in the description to Patreon and Facebook and that. Anyway, this is the Astro 30 saying, see ya, have a great day, and that was a pretty successful few hours.
Bye.